recently we have been promoted as professor, so it's a matter of great sense of satisfaction also, and to be at this positive position, and the list that was shown, in terms of publications, has crossed centuries in terms of about 120 publications now. Because that website is not updated, we didn't get time to update the website. So this being said, back to the business. So I've been given a task of speaking on non-parametric methods, and before I go specifically to this testing of hypothesis and the non-parametric, I would like to say one thing, that asking a statistician or a biostatistician which statistical test to apply is just like asking a clinician to give a prescribed medication. What type of medication should be given to a patient? Because there are certain conditions, there are different clinical conditions, there are different clinical scenarios, there are different pharmacogenetics properties of different drugs, different substances. Then you assess the weight, height, etc. of the individual. Then there is a case discussion, there is a case history, there is a elaborated process of documenting the clinical history of a patient before a specific medication is given. So likewise in statistics, what specific statistical test needs to be done, it's backed upon what type of data you have. What type of, whether it is unpaired data, it is a paired data, it's a longitudinal data, it's a pre-post data, it's a clustered data, it's unclustered data. There are many statistical assumptions that goes into the thing, and on the basis of that, we do a specific test that can be fall under the broad domain of, you say, a parametric test or a non-parametric test. So nowadays everything is quick. That is, everybody wants everything at a click of a mouse. Even among the residents we have seen, whenever their thesis submission is there, quick data is there. So we want everything in a day or two, and we have to submit our thesis. This is the usual thing, and it's understandable because as a resident and as a clinical staff and as a clinician, everybody is busy in many type of work. Especially the residents, they have to carve out time from their busy schedule to do the work. But at the same time, this should be understood that it is not a straightforward process that you do in SPSS or in Excel. For a very simple example, suppose you are using SPSS and you write a variable, let's say gender, and you code 1 and 2, 1 for male and 2 for female, and run the descriptive statistics. It will give you no error, because for computer 1 means male and 2 means female, and that is the number, and 1 2 1 2 1 2 you add on it, it will give you everything, but that is an error. Can we take average of gender? That is the thing. So we have to understand what type of data that is what we are using. So that's where I start. I always try to emphasize that this is important to understand your data first of all. If you understand your data, half of your work is done easy, half of your work is already completed, and one can move ahead. So these are the basic things that I will be covering. And if you try to see the growth of non-parametric literature in medical sciences over a period of last 40-50 years, the concept of non-parametric method was there in 18th century. It started around about 1700, but it kept on increasing. It kept on increasing after 1988, and in the field of nursing, it started somewhere in where I can click this. Oh. No, I have not put point something.
Laser.
Yes.
Okay, so one can see that in nursing it started somewhere in between 1990s, 1997, and there is a slight increase in this trajectory in terms of where it was a little bit stationary. It stood in 2016, it got elevated up, and in 2012 it got more up, and it has started going in upward direction. That means there is a plethora of application of non-parametric methods even in the field of nursing. This difference is explainable because if you type on PubMed non-parametric, this will give you this curve, and when you type non-parametric methods and nursing, it will give you this curve. So it will be a proportion of the total literature, and in nursing, what type of that has been done, that is there. So broadly, when we talk of any statistical approaches, classically, one can see them as two parts. One is what is called as descriptive statistics, and other is what is called as inferential statistics. So, for example, if we say that the mean age of all the participants in this workshop is say roughly 32 years with a standard deviation of say 2.5, this is what we mean by what is called as your descriptive statistics. That means we are just only describing our data. That means we are giving a numerical statements to our data. That is what is called as a descriptive statistics. But when we try to do some statistical testing, test of hypothesis, for example, whether the mean age of male participants is different from the mean age of female participants in this workshop, that forms the part of a inferential statistics. So that's the basic difference in the, one can say, the whole analytical process of statistics can be broadly considered into these things. Nowadays, even in literature, you will see artificial intelligence, machine learning, data mining, deep learning, neural network, artificial neural network, and many things. They also are using these two principles. Either they are describing the data or they are testing the hypothesis data already, but there is slight difference in them. They are a level up because they are either classifying everything into one thing or they are predicting something. So when you are classifying or you are predicting, that again goes into some either of the describing or making some inference. So that's the broad domain where one can understand. And under inferential statistics, when we do a testing of hypothesis, we can do a parametric test and a non-parametric test. Now there is a difference between a parametric test and a non-parametric test technically, and because of situation also. For example, if you try to estimate the age of the workshop, of all the participants in this workshop, it is not expected to be highly skewed. Means we can have a range of say 25 to 35, or you can say 30 to 45 will be a range. That means minimum of 30 years to a maximum of 45 years, with average say 35, 36 years with some standard deviation. Now, but suppose you take the platelet counts of individuals who are suffering from a dengue fever and admitted to a ICU. Their platelet count would have been in lakhs, say 1,50,000. After a few days, might be at the time of admission, they would have got 75,000. Then after some recovery, they would have got 25,000, 5,000, 1,000. So what is happening? A value is varying in the range of 1,000 to maybe 1 lakh or 1,50,000. So it's a highly variable data. It's a very skewed data. It's a very, you can say the range or the variance is quite high. So such type of data is subjected to a non-parametric test because where the variability is quite high. So these are the basic conditions. That means the distinction of parametric and a non-parametric test, that these tests, on the basis of parameter distribution, data assumption, data sample size and confidence interval. In parametric test, we are often saying it is parameter based because, for example, t-test, the average, the mean, that is a parameter. And statistically, the exact definition of parameter is that the statistical constants of a population is called as parameter. That means the thing which remains over a period of time as a constant and on the basis of which we can make some inference about the population from which that sample is taken, that is what is called as parameter. And the sample is the subset of that population which we try to take into account for that study. For example, the universe of all the nursing students or all the nursing faculty of all the nursing professionals in this institute would form a universe that will form the population of nursing individuals, and some of you who are the part of this workshop is a sample. So if I want to say whether the mean age of this sample is representative of the entire population or not, so we'll have to take your age, exact age, calculate the average, and from that the population we will try to see whether that age is representative or not. So that's where that means what is parameter is concerned. But what happens in a non-parametric? In a non-parametric test, we don't deal with some parameter. There is nothing what is called as a mean or a variance, because on the basis of mean and variance are the two basic construct of a parameter for anything, for any phenomenon. Because on the basis of mean and variance, many things else can be related and they can be calculated. And that are the two most important parameters to consider to describe your population statistics. So for example, when we say You estimate something and mean and variance comes out to be equal. That is the Poisson distribution. If mean is greater than variance, it's some other distribution. When mean is less than variance, there is some other distribution. So there are more than 125 statistical distribution, and on the basis of those things, we can classify the sample from which population it has been taken. So, but the basic distinction is that in the parametric and non-parametric test, what has happened? We don't, in a non-parametric, we don't make any assumption about the underlying statistical distribution. We just take the data as they are. So that's the first distinction. The second is that this is the one of the most, one can say, the demerit of a non-parametric. In a parametric test, what we do, we always take raw data. That means whatever exact value is there, we take them. For example, if we have to take the age of all your individuals, that is the exact age. But if I have to apply a non-parametric test, then I will rank all of you. That means I will arrange all the age values in ascending order and rank them 1, 2, 3, 4, 5. So what is happening? The raw data which was available has been converted into a ranked data. So what is happening? As a result of this, what is happening? That some of the information may be lost because the raw data which was in the original form has been converted into rank. That means the original form of data is lost. For example, hemoglobin level of say pregnant women who are pregnant in the range of say 9.5 to 13.5 has some relevance. But if you rank them, it doesn't make any sense. Because we lose the originality of the original data which was there in which we recorded. So that's the basic difference. And also many a times why we need a non-parametric test is, for example, many a times say Penny score. We have a scale, say one of the qualitative research that was going on. On many times you have an ordinal scale or a rank scale. It is not possible to measure quantitatively or in objectively manner everything quantitatively. For example, one can measure blood glucose level, one can measure the serum creatinine level, one can measure even the WBC count, many parameters. But if you want to measure pain, honesty, say beauty, say some recovery status, some quality rating, all these are ranked. You will take some scale, a Likert scale or a visual analog scale, and something will be rated on that. So that's the qualitative data. Technically, they can be called as a say a semi-quantitative data because we are taking a scale or some instrument and pointing it somewhere and then quantifying it. So semi-quantitative one can say. But technically, they would be ranked. And a small sample size and in confidence interval can be given in parametric test, but confidence interval cannot be derived in non-parametric test because we have ranked the data. So that's the another demerit. Its range is little less. So before we apply any non-parametric test, what are the considerations that we have to see for data? Then ordinal, nominal, or skewed, paired or unpaired. Anybody can tell what is the difference between paired and unpaired? Any one of you? अब तो चाय भी हो गया, नाश्ता भी हो गया. Anyone?
The data is from one group, then we can pair it. If there are two different groups.
Okay, मतलब some example.
Pre-test and post-test.
Pre-test and post. That means we measure something at one time point and we measure them again after some time. That becomes a paired data. And what is unpaired?
Control group and experimental group line.
Yeah, experimental group and a non-experimental group. That can be one thing. Or belonging to independent groups, one can say. That is what. And what is one sample?
Independent.
One sample and two sample. One sample means collectively as one unit, and two sample means two independent samples. That can be two independent, like mean age of male and mean age of female. Something of that is two independent. So that is paired. And what is longitudinal? You take a value at a baseline, then at first follow-up, at second follow-up, and third follow-up, depending upon the condition. That becomes your longitudinal data. So that's the basic 4 types of data that one gets. And that means data type and group are important to be considered than what exactly you are trying to do. So if we try to see the most basic type of statistical measures which we talk in terms of variance, correlation, and location values. In parametric test, it is mean standard deviation. For correlation, it is Pearson correlation coefficient, and for location value, it is mean plus minus standard deviation. However, for a non-parametric, it is median and mode. For variation, we say quartile and deviation and range. Many times in literature also, but I will demonstrate also, and even the residents used to ask me, sir, when we have a skewed data, should we report mean SD or we should report median and IQR? The best way is report it both. Because if it's a skewed data, then you report both because that makes your data description complete. And it will help you, it will guide you that what specific statistical test has to be done. For example, if you are reporting the summary statistics of a WBC count, it's a highly skewed data. Report mean SD and median IQR also both before applying a specific statistical test. So these are the basic tests, and under the parametric and the non-parametric, and how the statistical measures change, you can see. So when it's a representative value for average, where we say of average, it becomes median and mode. So when we try to do a Mann-Whitney U test, we say that the median of the two groups is same or not. That is the null hypothesis that we are trying to test. In the same way, when a variation, it is quartile and quartile deviation and range. For correlation, it is Pearson correlation and rank correlation. And for location values, it is mean ST, but it is for quartile or percentile. That means 25th percentile or first quartile, median or the second quartile, and the third quartile or the 75th percentile or the decile. These are the location values that we try to see. So one can see that under broad approaches of parametric and non-parametric, how the data changes and how the statistical measures also changes, that becomes important. This is the list of the common situations of two independent sample, two correlated samples, several independent sample, and several correlated sample. And the variable, if it is quantitative and qualitative, what type of parametric test needs to be done, and if it is non-parametric, then what type of statistical test to be done. So these are the distinction of, or one can say, analog of a parametric and a non-parametric that has to be seen. The time doesn't permit me to go into detail of all this, but whatever time is available, I will focus more on this. So these are the sign test, Wilcoxon rank sum test, Wilcoxon sign rank, Truskell, Wallace, Friedman, and McNamara. These are the basic non-parametric tests that needs to be done. Now see what type of null hypothesis and alternative hypothesis they are addressing. In sign test, we say that the median difference in pair is 0. Now what does this mean? The sign test is only based upon sign. For example, suppose anemic pregnant woman admitted to a gynae ward, measured their hemoglobin level, and after say first ANC and then second ANC you measure, and just you take the difference, and you are only interested in finding out whether it increased or decreased. For how many individuals the hemoglobin got improved, and for how many the woman hemoglobin level was not improved or remained the same. That means you are only taking into account the sign, not the magnitude. That is where the sign test is applied. In second is Wilcoxon rank sum test, is that one can say that the median across two groups is same. For example, the same situation, I arrange your male and female participants are there. We take their age and we rank them. They are two independent samples, and we try to see that whether the mean rank or say the median across these two populations are same or not. That is where the Mann-Whitney U test is done. Many a times there is what error people do in this is they either this spelling is being erroneously written, or Mann-Whitney, so Wilcoxon rank sum test and Mann-Whitney U test are the same. Always remember they are the same. They are not different. And they say that the median across two group is the same, and the null and alternative is that the median across two groups is different. Now, next extension is Wilcoxon sign rank. Now, in Wilcoxon sign rank, what happens? It is an improvement over this sign test. Where in sign test only the difference or the direction was important. If the magnitude is also important, that okay, there is an improvement or there is a deterioration in some health condition, but what is the magnitude of that deterioration or improvement? And we want to try to do that test. That is what is called as Wilcoxon sign rank test. Many times here also So we can say the null hypothesis we can address here is that the median difference across two groups is 0 and the median difference across two groups is different from 0. That means null and alternative. So one can see that what type of hypothesis that we are. You need not to take photos. It is there. It will be mailed to all of you. Okay, so concentrate exactly on what is there. So that is the difference. In Kruskal-Wallis, like we do one-way analysis of variance. For example, the mean age of residents in say palliative care unit, clinical care unit, and say in some medicine unit. It's independent sample. You want to do a analogous for a non-parametric in that situation, that becomes a Kruskal-Wallis, and in this case you say that the mean rank across 3 or more groups is synced. So when you have 2 groups, we define it to here, but it is 3 or more independent, we go for a Kruskal-Wallis test. And when we have a repeated observation, say baseline, first follow-up and second follow-up, then we go for a Friedman test. And when McNamara test is done, when we want to exact about count that means I will explain this thing. It's slightly different from other operators. So this is you. So one can see from all the list that what is happening. That one thing is very clear. Although we are not making any assumption about the parameter, but what is happening? We are totally changing the original form of data. That means the raw data has been converted into rank, either plus or minus. That means our original data structure is lost. And once in a clinical setup or in a clinical scenario, when we are observing some data, always the raw data, it has more weight as compared to a rank data, because any clinical decision can't be taken on rank. It has to be taken on the exact value, on the weighted data. That's why non-parametric test is not very widely used, but there are situations when there is no option other than doing it non-parametric. But one should know that this is the important limitation for applying a non-parametric test. So, for example, one more situation, suppose one is interested in doing a study on a non-steroid anti-inflammatory drugs for pain medication, and you can observe the pain score pre and post. That can be one situation. You can do NSAIDs for pain medication in medicine and palliative care unit. So chronic cancer patients or chronic patients are there at single time point. Then you can do, say, if you're interested in finding out pain medication with NSAIDs across 3 different specialties, and if you have across 3 more time points, and you have, say, across 2 different specialties, and suppose other is you want to assess the response of a chemotherapy in a locally advanced breast cancer patients, then what type of test should be done? Any rough guess for first situation, what type of test?